Okay, we are going to start talking about logarithms. And we're going to start with this equation here, 10 to the x equals 500. How do we solve it? At this point, we don't really have any tools, right? So this is an exponential function. And the thing we're solving for here, x, is in the exponent. And don't really know how to do that other than maybe we could try some stuff, right? It's going to be, let's see, 10 squared is 100, 10 cubed is 1,000. So somewhere between 2 and 3, right? But we could try some stuff. We could graph it, right? Here's the graph of 10 to the x, and here is y equals 500. So yeah, we could get a good estimate there. It's, maybe 2.75-ish. But what if we really want an exact number and we don't have to just plug stuff into our calculator? What we need is an inverse, right? We need to solve for this in a way that's efficient, right? So if this is our blue graph, the scale is different up here, right? This is 10 to the x. This blue graph is 10 to the x. What we really need is the inverse of that, right? So we're going to talk about the graph of this a lot more in the next section. But for now, the concept that we need is the inverse of an exponential function, and that is called a logarithm. So here's the definition. So y equals log base b of x is equivalent to b to the y equals x. Okay? So we're going to think about this a lot here. So let's see what we need. We need x greater than 0. We need b greater than 0, and b can't be 1. So those two conditions, remember when we're talking about exponential functions, we need the base here for an exponential function cannot be 0, and it can't be 1, and it can't be negative, right? So b has to be greater than 0 and not 1. That's sort of from the definition of an exponential. And the output here is going to be greater than 0, because that's going to be the case. If we have a base that's positive, raised to any power, our thing that comes out here is always going to be greater than 0. So that's going to be the case for our x, for our input here, right? So these are going to be inverses of each other. So let's see, we read log base this as the log with base b of x, or nobody really says that. Everyone says log base b of x. Log base b of x. That's how we read that. And it's also a question. Okay, so I'm going to come back to this because this is how I always think of it. This is asking a question. The question it's asking is, b to what power equals x? B to what power equals x? The answer is y. B to the yth power equals x. Okay? So since the logarithmic and exponential functions switch the x and y values because they're inverses, the domain and range of the exponential function are switched as well. So remember, for our exponential function, let's think the domain was 0 to infinity. So the range of the logarithm is 0 to, not 0 to infinity. Yes, 0 to infinity. Okay, let me start over. The domain of an exponential is 0 to infinity. So is negative infinity to infinity. The domain of an exponential is negative infinity to infinity. So the range of the logarithm are those values. The range of an exponential is 0 to infinity. So that's the domain of our logarithm. Okay. So these little arrows are also very helpful. If you're going from a logarithm to an exponential, going back and forth between kind of representations, if you have a log, start with the base. And you do these little, it kind of makes a little circle with these arrows. B to the y equals x. B to the a equals c. And you'd write it like this. B to the a equals c. So in my mind, these little arrows, this is how I do it. Okay, still have these little arrows. I start here, b to the a equals c. So here's some examples. Write these as exponents. Okay, so there's no variables here. This is just saying 6 to the 1/2. So how would we say this? Log base 6 of the square root of 6 equals 1/2. Or log base 3 of 9 equals 2. okay? That's how we say them. Now let's put these little arrows in. 6 to the 1/2 power equals square root of x. Yep, 6 to the 1/2 power equals square root of x. And is that true? Yeah, that's what it means to be the 1/2 power. And here, 3 squared equals 9, also true. All right, so what if we go the other way? We have exponentials, and we want to write them in the logarithm form. All right, so this is true. 2 cubed equals 8. How could we write that in logarithm form? Well, our base for our exponential and our base for our logarithm are the same. So base of our exponential, base of our logarithm is the same. And then the exponent goes over here. 2 cubed equals 8. So think about this one. How would you do that? 5, same base. 5 squared equals 25. So this, you could think of this as asking a question. 5 to what power equals 25? The answer is 2. 2 to what power equals 8? The answer is 3. How about this one? 10 to the negative 4 equals 1 over 10,000. So we're going to have base 10, 10, and the answer is 10 to what power equals 1 over 10,000? The answer is negative 4. 10 to the negative 4 equals 1 over 10,000. Okay. All right, so let's try to solve this without a calculator. This is asking a question, right? 4 to what power equals 64? Well, 4 squared is 16. 4 cubed is 64. So 3. 4 to the third power equals 64. Right? So think of this as a question. 4 to what power equals 64? How about this one? 3 to what power equals 1 over 27? Well, like 3 cubed is 27. It's in the denominator, so it should be negative 3. 3 to the negative 3 is 1 over 27. So the answer is negative 3. 3 to the negative 3 equals 1 over 27. So log base 3 of 1 over 27 equals negative 3. Okay, so we can do logarithms with any base, but there are 2 special bases. The first is base 10, and we call this a common logarithm. All right, so it's just a logarithm with a base 10. Okay, so here, if you just see something without a base written down, like log x, it's implied that the base is 10. Okay, these are the same thing. If there's no base and it says log, it means log base 10. Okay, so it just is equivalent to this. Log base 10 of x equals y, 10 to the y equals x. And we can just say log base 10 of x. So let's do this. Y equals log of 1,000. Don't use a calculator. Let's think of it. It's asking a question, right? It's saying 10, the implied base, 10 to what power equals 1,000? Well, 10 squared is 100, 10 cubed is 1,000. So it's going to be 3, right? 10 cubed equals 1,000. All right, so sometimes we have to find logs of things that aren't so tidy. If we tried to do this in our head, no idea, right? 10 to what power equals 321? I don't know, somewhere between 2 and 3, right? So how do you use your calculator? So you're going to have a log button on your calculator, L-O-G, okay? So you say log of 321, enter, and out pops this number. Okay, so try that. Get out your calculator, make sure you know how to do this so that you get this number. Okay, so we can find a log base 10 of any number. We just pop it in our calculator and out comes the answer. All right, here's an example. So logs are actually something that are used quite often in the real world. So one place they're used is for the Richter scale, right, for earthquakes. So the amount of energy released from one earthquake was 500 times greater than the amount of energy released from another earthquake, so much bigger. The equation 10 to the x equals 500 represents the situation where x is the difference in magnitudes on the Richter scale. To the nearest thousandth, what was the difference in magnitude? Okay, so this is what the Richter scale is. It's a logarithmic scale. So if the difference in magnitudes is 500, 10 to what power equals 500? Well, this is a log problem, and this is the same equation we started with in this little video, right? 10 to the x equals 500. That's the equation we started with. Let's write this in a logarithmic form, right? Because we didn't know how to solve this, but now we do. 10 to the x equals 500, right? We wrote this as a logarithm. 10 to the x equals 500. And now we just can pop this in our calculator. Try it, see what you get. The answer you should get is 2.699. Okay, so the difference in magnitudes on the Richter scale was 2.699. There was 500 times greater amount of greater energy. So this is like the Richter. So using logarithmic scales are ways, if there's big differences between things, and you don't want to be using like big numbers like 500, logarithmic scales are a way to like condense the scale down. Okay, so a difference of like 1 or 2 on the Richter scale means really big difference in how much energy was released in the earthquake. All right, the second base that we use is base e, right? The number e that we talked about talking about exponential functions. We call this a natural logarithm because, like I said, e is a number that shows up a lot in the natural world. So, log base e of x, we write using ln. Okay, it's kind of like backwards. We say natural log, but we write it ln instead of nl, right? ln stands for log base e. These are exactly the same things. Okay, so natural log of x is equivalent to e to the y equals x. E to the y equals x. And we read this as the natural logarithm of x, or the natural log of x. It's asking a question. It's saying e to what power gives me x? The answer is y. And y equals e to the x and y equals natural log of x. There should be an x right there. If you compose them, natural log of e to the x equals x. Okay. All right, so your calculator also has a natural log button. So if you wanted to evaluate this equation, natural log of 500, I mean, you could try to guess, but using your calculator is going to be the way to do it, right? So you push the ln button on your calculator, and then 500, and out pops, hopefully this answer, 6.2146. Okay? That's the end of this section. Just an introduction to logs. We will keep talking about them for the next several sections. Let me know if you have questions.